Okay, we're now located a mile or so downstream in the Potomac Valley from the previous stop. This rock is the Sykesville Formation, which is just a little bit younger than the Mather Gorge. It's a little different from the Mather Gorge in that it's considerably coarser grained, and as you can see on this face here, it does not show the very good distinct bedding that was shown in the previous outcrop. This is a much coarser grained and much more uniform rock here. And the layering that you do see running more or less in this direction was produced structurally when this area was put under high pressure and the rock was changed to a metamorphic rock. The unit itself, the Sykesville, is basically something out of science fiction, because although the Mather Gorge lies structurally above it, the Sykesville lying below came from the Mather Gorge. The Mather Gorge was pushed back up to the surface along a major thrust fault called the Plummer's Island Thrust, and when it reached the surface, pieces of the Mather Gorge broke off, eroded away, and were deposited in front of the thrust sheet as a unit consisting mostly of coarse-grained rock, including some rather large chunks. Right here, most of the chunks are quite small, sand and gravel size, much coarser grained than the material we saw in the Mather Gorge itself. But we will get to see some pieces that are much larger, boulder sized, and on the Virginia side of the river there are some pieces half a mile long that resulted from landsliding of the entire upper piece of rock down into the valley in front. This was a major puzzle to the early geologists who worked in the area, because they saw these units of rock half a mile long and they couldn't conceive of them as just being giant pebbles, and they couldn't figure out what the relationship of those units were to the other rocks in the area, because they just were sitting there out in the middle of nowhere. We know now that these are the results of enormous landslides where a chunk of cliff half a mile long slid off down into the valley and then was buried on the rocks in front. The fault itself then was folded, very tightly folded, into a hairpin shape. It's called an isoclinal fold. And then that isoclinal fold was itself refolded again. So this area has really been through the geological mill. Even more fun, over on the Virginia side, this whole episode was repeated at least 4 times, where a piece of rock was pushed up, folded, and thrust. Then that whole separate chunk was pushed up again and folded and thrust several times in a row. All of this was happening at a time when the eastern side of North America, the equivalent of North America at that time, wasn't having anything happen at all. It was as geologically active as the Gulf Coast today, which should be a real mystery. You can see those Gulf Coast type rocks that were deposited in a completely undisturbed environment over on the other side of Montgomery County, over by Sugarloaf Mountain. And it's as though these separate rocks at the two ends of the county were deposited thousands of miles apart on completely different continents. The reason for that is they were. This was not part of North America at the time. This was over on the African side of the ocean at the time. Later on, during the next few 100 million years, the ocean gradually closed and Africa and Europe ended up colliding with North America, raising the Appalachian Mountains. That only lasted for a short time though, because within 100 million years after that, they pulled apart again and the present Atlantic Ocean opened up. But a little piece of Africa and Europe stuck to the North American side, and that's what we're looking at here. So these rocks were actually deposited on the opposite side of the ocean on a completely different continent. But now they're perfectly good North American rocks. They've become attached to North America. Interestingly enough, if you go to the coast of Norway or to the outer islands of Scotland, you'll find that it worked the other way too. Some little pieces of North America stuck to the European side as well. So we sort of swapped pieces of rock. Now, I have here a small piece of the Sykesville Formation that I broke off so you can see fresh rock here, and you can see the individual grains on here. They're much coarser grained, and some of the minerals in here are formed only under high temperature conditions. So this is a metamorphic rock, a low-grade metamorphic rock. A couple of other things to see. Okay, right here we see this layer of white rock here cutting through the Sykesville Formation. This is a quartz vein, pure quartz. This wasn't deposited as molten rock. It turns out quartz has an extremely high melting temperature, and the surrounding rock here shows no signs of having been heated that much. This was deposited by a very hot water, extremely hot water solution, which dissolved the quartz and then redeposited it in cracks and crevices in the surrounding bedrock. This was deposited after all the deformation because the vein itself cuts straight through and shows no signs of deformation at all. So this is post-deformation. Quartz veins themselves are actually very common in low-grade metamorphic rocks, and the quartz veins in this particular area are of extreme interest because they are gold-bearing. There is gold in these quartz veins, and here in the national park, in C&O Canal National Park, there are old gold mines which probably could be worked profitably for gold today. They were abandoned over 100 years ago because it cost more to get the gold out than the gold was worth. Gold was worth maybe $20 an ounce then, and it cost more than that to get it. Gold is, what today, $1,500 an ounce? Get that gold out today, and if it costs $100 an ounce to get it out, you make a really good profit. There is only one difficulty. It's in Montgomery County. And what do you do with the millions of tons of waste rock that are left over after you get the gold? People are not going to be very happy if you cover a square mile of Montgomery County with waste rock. And if you have to ship that waste rock out somewhere else, there goes the price of extracting the gold. It becomes not economic to get it out. No, there are true gold mines working today in Montgomery County. They're called real estate offices. So the gold now stays in the ground.